Hello students, welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be going through the topic of algebraic fraction simplification. This topic is one of the most highly requested videos that I've been getting from students right across the CSEC classes that I've been teaching over the past 2.5 months, and so I'm here to bring you this video so that it may be able to assist you with clearing up any ambiguity that you may actually have with this topic. Now, this topic is a fairly easy topic to some extent. There are aspects of it that students tend to get a little bit mixed up, so hopefully this video will be able to give you some clarity on that area then. All right, if this is the first time here on the channel, I do provide contents as it relates to the CSEC, CCSLC, SEA exam or math exam curriculum. So be sure to hit that subscribe button below, turn on the post notification bell to be notified on a weekly basis whenever I post review tutorial contents, exam review papers, so on and so forth. All right, this channel primarily will help you to develop a better understanding when it comes to thinking through exam papers. All right, so be sure to hit the like button as well. Leave your thoughts and comments in the comment section box below and let me know if the video is of any value to you. All right, so let's get right into it here. Of course, we're going to be finding here that two other concepts which would have been discussed on the channel will be overlapping with this topic here. We discussed previously on the channel the distributive law, and we also discussed the topic of binomial expansion. So a little bit of that, or a little bit of those two topics, will be overlapping with this one. So I'm going to do my very best here to guide you through how to know what to do when given a particular question. Let us start off with the usual, giving you a little explanation of what is meant by algebraic fraction. Well, it says here that simplifying an algebraic fraction is very similar to when you're simplifying a numerical fraction, where adding and subtracting requires us to find the lowest common multiple. And of course, when you're multiplying or dividing, it's going to be more or less the same principle, where we simply cancel numerators with denominators, and we are going to also as well reciprocate the divisor and change the division sign to multiplication. I'll be going through the multiplication and division aspect of this in part 2, so be sure to hit the subscribe button below so you can be notified whenever that video comes out. All right, but we're going to be scaling through about 8 or so questions here, so let's see exactly what we can do. So the very first question that we have on screen here is, in fact, we're asked to simplify x over 4 plus x over 5. And as I said in the instruction earlier, that when you're adding and subtracting fractions, the very first thing you want to do here is that you want to find the LCM. So in this case here, our denominators are very much numerical, so it's very easy to say that the LCM here is 20. That's 4 times 5 is 20. Then of course 4 into 20 goes 5 times. We're going to put that 5 at the top here. And 5 into 20 goes 4 times. Put the 4 at the top here. Now 5 times x here is in fact 5x. And 4 times x as well here is 4x. So we are going to get a simplified result here of 9x over 20, or 9 over 20x. All right, so that pretty much gives us the simplified version for this. Now, in the event that you end up with a number at the numerator here that's larger than the denominator, we don't usually have to convert it to a mixed fraction. We don't usually convert mixed fractions in algebraic fractions. We just leave it as it is then and there. All right, so that was a pretty easy question, nothing too challenging there. Let's look at another example then, where we're going to be finding the numerical LCM here. So again, the LCM here is in fact 35, so that's 5 times 7 is 35. 5 into 35 goes 7 times, and 7 into 35 goes 5 times. 7 times 3 is 21, and that's 21x, and 5 times x is in fact 5x. So the first example was addition. The second example here is subtraction. Here what we're looking at is 21 take away 5. That's going to be equal to 16x over 35. All right. Now, quite a few teachers, we do have this mental trick that we do. I've not shown my students that it can be mentally looked at this way. You find that a lot of teachers will show you a shortcut where we use something known as the butterfly technique or the butterfly method. So what we normally do here is that we normally go left side here. So we go here, 5 times x is 5x, and we go 4 times x is 4x, and then we add them together. We get 9x, and then what we do then is that we multiply the two numerators and we get the denominator. Now, I'll use that method depending on the complexity of the problem, depending on if I'm working a particular math problem and fractions seem to come involved. Like maybe if I'm working out an indices problem and I have to add fractional powers, I find it a little bit tedious to have to keep finding the LCM every time. So I'll use this technique. Now, you can actually verify if your answer is correct by just mentally looking at it that way. But whenever I tell my students that you can cross multiply, they sometimes ask me, how can you cross multiply when you're subtracting? So that's usually why I don't normally tell my students to cross multiply, but mentally that's really what we're doing. If you notice here that if I take the 7 here and I multiply it by the 3x, I'll get 21x. And if I multiply here, say the 5 times x, I'll get 5x, and there's a subtraction sign here. And if I multiply the 5 by the 7, I'll get 35. So that somewhat kind of lets me move a little bit faster in terms of the simplification process. But that method doesn't work. Well, it works, but it sometimes gets a little confusing as we go deeper and deeper into the different types of problems then. All right, so if you want to use that method, guys, that's also okay, right? But definitely I think that the most ideal method here is to just go ahead and find your LCM. Now let's move on to here, say question 3 and 4. Again, we're going to be looking at finding the LCM, but we have done a little flip here. As opposed to having the LCM being numerical, we are now having, as opposed to having our denominators being numerical, we're going to have our denominators being, say here, algebraically written or in algebraic variables. So here, once again, we're going to have to find the LCM. And so the LCM here is going to be a case where, of course, if numbers are involved, then obviously 5 times 3 is going to be equal to 15. If numbers are involved. And then of course here is where it gets a little tricky sometimes, because then students tend to go ahead and say x times x is in fact x squared, and so 15x squared is a multiple, but it is not the lowest common multiple. So what I always tell my students, that if you do it this way, you're going to eventually gonna have to simplify, and I'm gonna show you that in a minute. I'm gonna show you that you can still use 15x squared, but you're literally making your job a little bit harder. So we're gonna go ahead here and use the lowest common multiple, which is in fact 5 times 3 is 15. And so when variables are involved, especially if they are the same variables or same base, we tend to use the variable with the lowest power. Let's repeat that, guys. When you're finding the LCM involving variables, you're going to be using the variable with the lowest power. So here, there's not a difference in the powers. The power here of this x is 1, and the power of this x here is 1. So our LCM here is just going to be simply 15x then. All right, so here's how we do it then. We say 5 into 15, that goes times 3 times at the top here. And then we try to find out how many times can x go into x. Well, x into x goes 1 time, or we just simply say x cancels x. So therefore then 5x into 15x goes simply 3 times here. And once again here, 3 into 15 goes 5 times. And of course, x cancels x, or x into x goes one time. 1 times 5 is still remains as 5. So then we have here 3 times 4 is 12, plus say here 5 times 3 is 15. So we end up with very similar answer of 17, say here, over 15x. That is our simplified answer. And as I said earlier, prior to getting to this answer, we don't usually convert, say here, 17 over 15 as a mixed fraction. We just simply leave it as 17 over 15x, or 17/15ths x, if that's what you want to refer to it as. Let's do an example here with subtraction, but this time we have different powers. So once again, the LCM here is going to be, say here, there's no numbers. Well, there's only one number involved here. If there was like a number here, like say 3, then we'd simply say 3 times 4. But there's only 4, so the 4 will eventually come back a part of the LCM. And so here, x squared and x cubed, for you to find the lowest common multiple, you've obviously got to use the variable with the highest power. Use the variable with the highest power. All right, highest power. So therefore then it's obvious that we can get x3 from x3, and we can get x2 from x2. All right, now the 4 will eventually come back to the top here, because in front of this x here is an understood coefficient of 1. So basically 1 into 4 goes 4 times. Okay, and then now here's where we're looking at using the laws of indices. Now when I'm teaching my students, I don't usually tell them that the laws of indices is what we're using. I usually bring the lesson across in this form here, that there's 3 x's here and there's 2 at the top here, therefore 1 is left at the top here. Okay, so that's how I normally explain it to my students until they get a hang of the concept. So basically what we're saying here is that x3 divided by x2, or x2 into x3 goes x times. Okay, lots of students tend to have a little bit of difficulty when you bring across the lesson like that. I've experienced this for the better half of 10 years, especially with students who are doing crash courses, or they're learning algebra for the first time, or they're learning algebra. You know, a lot of students tend to have a loath towards algebra. So sometimes just the way you bring across the lesson will give them a better understanding. So here's how I'm going to be doing it in this video. I usually say there's 3 x's at the bottom here, and 2 is extracted in the denominator here. That means 1 is left in the numerator, and that's how I bring across my lesson, guys. Okay, all right, so now we have 4 cancels 4. Obviously 4 into 4 goes 1 time. I don't think I need to put times 1 here, because times 1 is just going to be more or less the same, so I don't usually put the times 1. But if you want, you can put the times 1. And x cubed cancel x cubed. Now whenever it is that the numerator goes exactly into the denominator, pardon me, whenever the denominator goes exactly into the denominator here, or the LCM here, then usually that's the only time that I'll write my 1. Okay, so here 4x cubed into 4x cubed goes 1 time. That's the only time that I'll ever write the 1 here. Okay, otherwise there's always going to be something left over, which I don't need to write the 1, because the 1 is an understood coefficient. Okay, so that's the only time I write the 1. Now what we have here is 5 multiplied by 4x, that gives me 20x, and 2 multiplied by 1 here gives me 2. Now unfortunately I'm not able to go any further here, because we are not allowed to subtract or add unlike terms. So therefore then my answer here is 20x minus 2, all divided by 4x cubed. All right, that could be simplified a little further, but we're not going to be going too much in depth into the simplification process. For now, this is an acceptable result here. So you usually want to just go ahead here and just make a conclusion. That's going to be 20x minus 2 all over 4x cubed as your result. Now, I did mention to you earlier that I'm going to show you that in the event that you make the error, and I wouldn't necessarily call it an error, I'm going to say in the event that you make the question, the simplification process, a little bit harder than it's supposed to be, here's where I can say that if you go ahead and you say the LCM is, say here, 15. Let's do that better. Let's say you have the LCM here to be 15x squared. Then, okay, 5 into 15 obviously goes again here 3 times, okay? And then let's say x into x squared goes x times. All right, let's do it like that. Okay, so let's just remove this here and put like a little dot so we don't get it confused. So that's 4 times 3x, okay? And let's then say that you say x again into x squared goes again x times. Okay, so that's x here. Let's remove this and put a dot. Then what we're going to end up with now is 4 times 3x is 12x. And 3 times 5x is 15x. So we're going to end up with, say here, 17x. Pardon me. We're going to end up with 12 plus 15. That's going to give us, say here, 27x. So that's going to be 27x. All right. And then that's going to be divided by, say here, 15x squared. So then we're going to have to reduce this here. And then we're going to say 3 into 27 goes 9 times. And 3 into 15 goes 5 times. And then x cancels x into x squared. It just pretty much makes the problem all messy, right? So based on what I'm seeing here, we're actually going to get an incorrect result by using the multiplication of the variables. Which is why the idea is that whenever we are going to be finding the LCM, we want to actually use the variable with the highest power as our LCM. So disregard what it is that I've just shown you here. I'm just showing you that in the event that you do not use the correct, say here, LCM, you're going to eventually end up with an incorrect result here. All right, so that takes care of that particular problem. Then let's move on then to, say here, another example. So now we're looking at question, say here, question 5, and you're gonna find here that we get some interesting questions, some questions that usually can't go any further than just finding the LCM. So here, what we're looking at here is in fact finding the LCM of two unlike terms. So now what we end up here with is in fact 7 times 2 is 14, and so there is, because the variables are different, then we have to merge them together as one. So the LCM then here becomes 14xy. If they were like, say for example, same variables like x squared and x4, then we would of course use the variable with the highest power. So they are different, so we just merge them together here. Now notice here that the 7 goes into the 14 2 times, and the x will basically divides into the x 1 time. Again, we don't usually write the 1 because 1 times 2 is still 2. And then of course what is left after the division is y, so that y goes at the top there. All right, and then again we say 2 into 14 goes 7 times. All right, and 2 into 14 goes 7 times, and again the y cancels the y, which goes 1 time, or y into y 1 time. We don't usually write the 1 because 1 times 7 is still 7. And then of course, say here, the x is left at the top, then say here. Okay, so 3 times 2y is in fact 6y, and 5 multiplied by 7x is going to give us 35x. Now, as we speak here, this cannot go any further because we are not allowed to subtract unlike terms. So our final result, or our final simplification process here, is 6y minus 35x divided by 14xy. This question tends to come across as a little bit of a shocker for students because they tend to feel like there is more to be done when there's actually nothing else that you can actually do. All right, if you're planning to do something else, you're pretty much planning to you're pretty much planning to reverse the question back to where it's coming from. That's the most that you can do. But at the moment here, 6y minus 35x divided by 14x xy is our simplified answer. We have a very similar question on the right side here where we're adding in this case. So once again, the LCM here is going to be, say here, 15. This time then we only have a y. Okay, there's no variable over here, so just the y comes back down here. Once again, if this was, say for example, y cube, then we would use y cube as a part of our LCM. But only y is there, so therefore our LCM then is 15y. Now 3 into 15 obviously goes, say here, 5 times, and nothing cancels the y, so the y is going to also join the 5 that is at the top here. So basically 3 into 15y will actually go 5y times. Okay, and so 5 into 15 goes 3 times here. And see here, the y will basically go into the y one time, or we just simply say y cancel y. So that goes one time. 1 times 3 is still going to be 3. So we don't usually write that 1. Okay, so 5 times 5 gives us 25. And x times y gives us xy. And that's going to be plus 4 times 3 is 12. Once again, we end up with another example here where we are not allowed to go any further because of the unlike terms. So our final result here is 25xy plus 12 divided by 15y. Okay, that is our final result then. Okay, now we're going to be moving on to some more interesting questions then, where not only are our denominators algebraically written, but they're algebraically written as well as in the form of a binomial expression, and that tends to make the question get a little bit more tricky in terms of its appearance. Now let's take a look at the first example then here. So here what we have is, it's pretty much, you can safely say that it's pretty much impossible to literally find the LCM of, say here, an algebraic expression here. It's very difficult to look at this and be like, oh, the LCM is 6x or 5x or 25x or 35, or, you know, it's not numerical. So whenever you end up with a situation where your denominators in your fractions are algebraic expressions or binomial expressions, we tend to always simply join them together, separated by a bracket like so. So we have this 3x here and this 2x minus 5 in a bracket. Now, I always put my binomial expressions in a bracket. If you want a review on what is a binomial expression, do check the video out in the link that is linked in the description box below. You'll get a better understanding of what is meant by a binomial expression. Definitely check that video out, guys. I will place a link right here in the cards for you. So here, this binomial expression here, 2x minus 5, is merged with the 3x. Now, I tend to always put my monomial expressions in front of my binomial expressions. Now, just so that a student may have this question, is it okay if I put the 2x minus 5 and the 3x over here? That's also fine. You can do that. I don't usually put my single expressions in a bracket. If it's single, I leave it as it is. But once it's binomial, it goes into a bracket like that. But I kind of prefer writing my monomial expressions to the left and my binomial expression to the right. Now, here is where we're looking at a more mental approach to this, okay? Because it's not numerical where you can actually say 3 into 5, 3 into 6 goes 2 times, or 4 into 12 goes 3 times. Here, if I were to ask a random person that's walking on the street, how many times can 2x minus 5 goes into 3x, open bracket 2x minus 5, they wouldn't be able to directly give me an answer. But how we look at this is, say here, 2x minus 5 basically cancels 2x minus 5 and leaves us with 3x. So the 3x goes at the top, say here. Okay, that's how you have to look at it. And so here 3x basically again will cancel this 3x here, leaving us with 2x minus 5. So it's a mental approach more like to this type of question here, where we're basically crossing out terms. So 3x cancels 3x, leave us with 2x minus 5. Now, once you find that a binomial expression is what you have to write at the top, that's when now I usually carry my brackets. So I'll say open bracket 2x minus 5. Now, what happens then? You may be asking yourself, what happens then if I don't carry it in a bracket? Then what usually happens, students, is that it tends to give an ambiguity in terms of its appearance, because students will often make the mistake by saying 5 times 2x, but they will also tend to forget to multiply the 5 by the 5. And why I can safely say this is because over the years, based on the types of students that I've taught over the past 10 years, I often see that students with fundamental algebraic, when they don't have a proper structure or a proper fundamental understanding in algebra, they tend to make the mistake by not distributing the 5 here. So I often do one of two things. I'll often tell my students, hey, when you're bringing up a binomial expression to the numerator, always bring it up as a bracket, because then that kind of tells the student that the 5 on the outside has to be used to multiply whatever is onto the inside. Now, for some reason, this tends to come across a little bit tricky for students. Sometimes they do perhaps look at the problem as being a little bit challenging. So what I recommend though is that if you end up with a question where binomials are involved, try to write your results on the line as opposed to going at the top here. So let's go back to this question here. 2x minus 5 cancels 2x minus 5, leave us with the 3 at the top comes down on the line, and then that multiplies, say here, so this cancels this, so the 3 at the top comes down on the line and multiplies the 3x here. I tend to now start writing my results on the line. So this cancels the 2x minus 5, leaves us with 3x, and the 3x multiplies the 3. Now say here 3x will cancel the 3x, leave us with 2x minus 5. Again, I like to write my numerical values on the outside of my binomial expressions. That's how I prefer doing it. When I do it like that, it tends to give me a clearer idea of my next step. Now, for the student, I recently had a conversation with a student that says they are not able to ask me questions. A lot of my students kind of prefer face-to-face teaching, and whenever I give them face-to-face teaching, I often recommend videos to them. They often tell me that sometimes they cannot learn from watching videos because you're not able to ask questions. So I often try to answer as much of the questions that I think that you might possibly ask. Here's another question that I think a student might ask, or students have asked me before. If I say 3x cancels 3x, goes 2x minus 5. If I write the 2x minus 5 like this, and then write the 5 on the outside, is that okay? That is also okay, but understanding that the 5 must still distribute into the bracket here. And when you do it like this, when students distribute the 5, they forgot that the negative also is attached to the 5. So I find that it's just easier to have a method that works all the time. Once you end up with binomials and single values, you always want to write the numerical values in front of the binomial expressions like this. Once you do it this way, then you won't have any problems then. Alright, so that's 2x minus 5. Now going back to the method that I showed you in question 1 and 2, where I say to you that mentally, guys, you could actually do it this way. So you could actually go ahead and say 3 multiplied by 3x and write it down here, and then you could say 5. Notice now that it goes here, so the 5 then, the minus 5 then multiplies, then you have to remember that this 2x minus 5 has to go into a bracket. So let me know in the comments which method is most best or is best for you, which way is you find easier to get to your answer. Let me know in the comments down below. But in the meantime, let's get back to this question here. 3 times 3x gives us, say here, 9x, and we're going to be distributing the 5. Now, duly note that the sign on the outside will generally affect the sign on the inside. So that's also another mistake that students make when they eventually get to the answer. They often have a sign error. So minus 5 times 2x gives us 10x, and negative by negative gives us positive. 5 times 5 is 25, and that is all over 3x open bracket 2x minus 5. Now I'm using the opportunity here, guys, to go through all the possible questions. If there's a question that you have, it will most likely be answered in this video. That is why I'm elaborating on a lot of the different things, because during my 10 years plus experience teaching middle school or teaching students at the CSEC level, these are common mistakes that you all make. These are common ambiguities that somehow floats in your mind. These are the common errors that will affect you getting to your results. Okay, so here what we have now is just basically two like terms here. 9x minus 10x, that gives me here negative x. Please review my integer video so you can be very much aware of why this is actually negative x as opposed to being x. So that's negative x plus 25, and that's going to be all over 3x open bracket 2x minus 5. All right, that pretty much gives us the answer to that particular question. Then we're going to be moving on to yet another example here. All right, and so for this particular example, then we're going to be actually finding, say again here, the LCM. So the LCM here once again is going to be a combination of binomial expressions. So what we have here is, again, say 2x 2 minus x in bracket multiplied also by 3x minus 2 in bracket here. Once your denominators are in fact binomial expressions or algebraic expressions, we merge them together. Now, since they're both binomial expressions, we've already mentioned that as long as there's a binomial expression involved, most likely it is best to put it in a bracket here. So as we've been doing before, using this mental approach here, we can see 2 minus x cancels 2 minus x, leaves us with 3x minus 2. Because it's binomial, we're going to bring it on the line, so we end up with 4x open bracket. This 4x at the top comes down on the line, and then because what is left is 3x minus 2, that goes right here. Okay, and then obviously then 3x minus 2 cancels 3x minus 2, leave us with 2 minus x, but it's a binomial, so it goes just after the numerical value that is at the top here. This 5 comes down on the line and goes, say here, 2 minus x here. All right, now we can go ahead and we can distribute. We can distribute the terms here. So the 4x gets distributed with the 3x, and the 4x gets distributed with the minus 2. The 5 gets distributed with the 2, and the 5 gets distributed with the minus x here. Lots of students tend to always distribute, but only distribute once. Once again, guys, as a reminder, when you're distributing, remember that whatever is on the outside of the bracket must be distributed with whatever is inside the bracket, however many terms there may be. So 4x multiplied by 3x gives us 12x squared, and 4x multiplied by minus 2 gives us minus 8x. Distributing again, 5 times 2 gives us, say here, 10, and 5 times minus x gives us minus 5x, and this will be all divided by 2 take away x all over 3x take away 2. Now let's observe to see if there's any like terms that may be at the top here. If you guys want to group, you can say 12x and group the 8x with the, you can group the minus 8x with the minus 5x, but I think that most of you guys here who are watching will obviously understand that minus 8 minus 5 gives us minus 13. Lots of my students use the O-have technique. That is, you O8 and you O5, so you end up owing 13. Those are the only two like terms that are on the line, and then the plus 10 will come back here. And this is going to be all over 2 take away x over 3x minus 2 here. All right, and that is in fact our simplified answer. Now, a couple of my students did in fact ask me, sir, what if it is a case where I may have written the minus 13x followed by the 12x squared by the 10, or if I wrote the 10 first and the minus 13x then the 12x squared, would my answer be incorrect? Absolutely not. Your answer would still be incorrect, because the order in which you write down your result will not change the result, because at the end of the day, none of the terms can be simplified. So therefore, no matter the order you write it in, you're going to still be awarded the marks. I do recommend though that you get into the habit of writing down your answers in descending powers. What do you mean by descending powers? It means I always tend to write the highest power in my answer first, followed by the next highest power, followed by the next highest power. So here, this is the power of 2, this is the power of 1, this is obviously the power of 0. There is no variable here, so it's really x to the power of 0. So when you write it like that, it tends to give a more uniform result, uniform display of the result. So I do recommend that you practice writing your answers in descending powers. All right, let's move on then to some more exam structure type questions then. And this particular one, let me check to see this is the only one here. This is probably the most common exam structure type question that you're going to be meeting up on. If you end up on a CXC exam or one of my end of month or end of term exams, you most likely are going to see an example like this one. So for my students who are watching this now or in the future, most likely, as I said, this is the kind of question that usually comes on an exam paper. So once again, we're going to be finding the LCM here, which is in fact going to be, some students will use 8. Again, as I said, when it's numerical, guys, you can use any multiple, but it's recommended that you use the lowest common multiple. I did explain to my students in the numerical aspect of fractions that whenever you're finding difficulty in finding the LCM, multiply the denominators, which tends to most times give them the LCM. But there are times, for example here, where if you multiply, you don't necessarily get the lowest common multiple, you end up getting a multiple, which causes you to then have to simplify when you get down to this stage here. So here I'm just going to be using the LCM here of 4, because 4 can go into 4 and 2 can go into 4. Again, if you use 8, that is also just as correct. Okay, so 4 into 4 goes 1 time. Remember, we write our answer here and bring down our numerator here. Remember, we always write the numerical value in front of the binomial expression, and the binomial expression will always come down with a bracket. Now you might ask, do you have to write the 1? You don't have to write the 1, but what I really find is that if it was a case where, let's say the 4 was on this side, let's just look at it then. Let's say that I placed the 4, let's say 2 was here and the 4 was here as opposed then, and we say 4 into 4 is 1. What usually happens is that students don't realize that the sign outside is going to be affecting the sign on the inside. So I do strongly recommend, even though for some persons, as I said, most of these videos are for students who are not a big fan of algebra, or they find algebra very challenging, you know, just putting the 1 there, it's not necessarily needed, but just as practice, just so you avoid any little mistake that might seep in and cause you to get the question incorrect, I do recommend though that you write the 1 just as practice, but you don't necessarily have to write the 1. Okay, so 4 into 4, yes, goes 1 time, times the top. Okay, and then say here 2 into 4 goes, say here, 2 times. Remember, you bring down the sign, 2 times, open bracket, bring down our numerator, our binomial expression numerator into a bracket here. Then we're going to be going ahead and we're going to be distributing here. Now, it doesn't make sense to really distribute the 1 because, of course, due to the multiplication by one identity, 1 multiplied by anything literally gives you back the same thing. So that's going to be 3 minus 2x. Now we're going to be distributing the minus 2. Minus 2 times 3x gives us minus 6x. And watch now, negative times negative gives us positive. 2 times 5 is 10, and that is going to be all over 4. Okay, I think I ran out of space here, guys, so bear with me here. Looking for the like terms. Obviously we have the minus 2x and the minus 6x. So if I owe 2x and I owe another 6x, I end up owing 8x. And here we have the numerical values 3 and 10. So 3, positive 3 plus 10 is 13, and that's going to be all over 4. All right, so for some of my students, if you want to write an extra line, an additional line with grouping, that also works. If you're at that level where you can look at the problem and be like adding or subtracting no matter the order that it's in, then you can also do that. You'll get full marks for your result then. All right, we're almost coming to the end of this video, guys, so let's wrap this up. LCM here once again is going to be, say here, 2 binomial expressions. So here what we have is 3x minus 4, and then we have 5x take away 1, say here. All right, and we've looked at an example like this, as I will drag back the screen here, where we looked at this example where if the denominators are binomial expressions, we merge them together. So it's the same principle here. So 3x minus 4 cancels the 3x minus 4, leaving us with the 5x minus 1. But remember that there's a numerical value at the top, so this comes down here. That's 5. Open the bracket, and we write what is left. Then say here, 3x minus 4 cancels 3x minus 4, leaving us with 5x minus 1 here. Minus, then 5x minus 1 cancels 5x minus 1, leaving us with 3x minus 4. Remember that goes last because the 3 comes down, and 3x minus 4 goes into the bracket. Then say here, so 5 times 5x, 5 times minus 1, minus 3 times 3x, minus 3 times 4. Let's go ahead and do that. 5 times 5x is 25x. 5 times negative 1 is minus 5. Minus 3 times 3x is minus 9x. Minus 3 times minus 4 is positive 12. And that is going to be all over 3x minus 4. And we're going to have 5x minus 1. Again, as I said, guys, if you want to group, rewrite another line and say 25x minus 9x minus 5x plus 12, that's also fine if you're a little bit timid in terms of getting the result. But if you have been watching all my other previous tutorials, you most likely will be confident enough to see that 25 take away 9 is in fact going to be 16x. And if you owe 5 and you end up having 12, paying what you owe will leave you with an amount of 7. And that's going to be all over 3x minus 4 by 5x minus 1. And that is going to be your simplified result. All right. As I said, some of these questions will pop up oddly in your exams, not just my end of month or end of term exams, but in general. We don't know what CXC is going to send come, or CCSLC. We don't know what level of math they're going to send come. So we've just got to be all rounded, prepared for whatever may present itself on paper. And so this final question here, as I said, looks quite interesting in terms of its approach. It looks easy, but then let's see what happens in this particular question here. Here, easily, our LCM is just going to be a merge of the 7 and the 2x minus 5. So let's see here. 2x minus 5 cancels 2x minus 5, leave us with the 7. If you want, because it's numerical, we could just simply write down the 7 up here, or you could just bring it down and say 3 times 7. I kind of like doing it this way, bringing the answer down on the line. And so watch this example now. The 7 cancels the 7, and now we're left with 2x minus 5. Now 5x minus 4 is a binomial. So do I just write down the 5x minus 4 like this and then put this into a bracket like that? Well, if you do that, that's going to be most likely incorrect, because as long as a binomial is involved in your answers, the binomial has to be in a bracket. Now, if you don't have that bracket there, you most likely will be tempted to do something like, say, distribute the 4 here, and that's going to be very incorrect. Okay, remember that if a binomial expression, please review my binomial expansion video to get a better understanding of what is meant by binomial expressions. If a binomial expression is involved, students, please remember to insert the binomial expression into a bracket. All right, like that. Now, due to the fact that that now becomes the product of two binomial expressions, 3 times 7 here is 21. What's going to happen here is that we're going to have to distribute using the binomial method, the distribution law for binomial expansion. A video was completely done on that topic, so review that. The link will be in the description box below, or just check the playlist in my channel description. So here we're going to be using the 5x to multiply the 2x. I'm going to be using the 5x to multiply the minus 5. We're going to have the minus 4 multiplies the 2x, and the minus 4 multiplies the minus 5. Remember, we're going to be using that distribution technique, the foiling method. Okay? So then, let's go ahead and distribute. 5x multiplied by 2x will give us 10x squared. 5x multiplied by minus 5 gives us minus 25x. Moving on to the next term, minus 4 times 2x gives us minus 8x. And of course, minus multiplied by minus is positive. 4 times 5 is 20. Once again, everything here will be all over 7 open bracket, 2x minus 5. Now we're looking for all the terms that are alike. Now, as mentioned before, I kind of recommend that you guys practice writing your answers in descending powers. So I'm going to rewrite my 10x here, 10x squared here first. Then I'm going to be moving on to my grouping my x's. Then this is the only time that I recommend that you actually group. Okay, so that's minus 25x minus 8x. You just want to be extra careful, extra meticulous when it comes to getting your answer, because it doesn't take much for you to get this question incorrect. It just takes for you here to just write down one incorrect sign and game is over. Okay, and that's going to be over 7 2x minus 5 then. So now that everything is grouped nicely in order, then our final answer is going to be 10x squared. Here I owe 25 and I owe another 8 on that 25. So apparently I'm going to be owing 33 x's, and then 20 plus 21 gives me 41, and that's going to be all over 7 open bracket 2x minus 5. All right, and that brings us to the end of that particular question then, and this actually brings us to the end of this particular tutorial. All right, so I do recommend that in the event that maybe some of the questions weren't really clear, just replay the video and just take your time. I do recommend that you also go onto Google and type in algebraic fractions worksheet, put PDF at the end. You're gonna find that you get a document to which you can download practice questions, and you can actually use this video as a guide to improving your skills on algebraic fractions. All right, so I want to thank you all for staying with me for the better half of 45 minutes, and I do hope that this video was of some value to you. It did clear up any questions that you may have. Hopefully, if you may be doing an exam and you meet upon this video was helpful to you. Do look out for part 2. We're going to be looking at algebraic fractions involving multiplication and division. So until then, I'll see you next time in another tutorial video. Do not forget to hit the subscribe button below, turn on your post notification bell, hit the like button. It really does help the channel to grow. Leave your thoughts and comments into the comment section below, and I'll see you in another tutorial video. Take care. My name is Akin, your math instructor. Goodbye until next time.